Since the use of the z-score is so important, we'll provide some additional practice for you with the z-score formula and the normal distribution. Remember, with the normal distribution, it's important to recall that the distribution is such that 100% of the observations fall under the normal distribution. Using your knowledge about standard deviations, you can determine what percentage of observations fall within certain areas around or between, above, or below particular values on the normal distribution. If you think about this, we have some standard scores. We have a z-score and a t-score. We have percentiles and standard deviations. Those numbers below this distribution always stay the same. They will never change. They'll always be the same. How do you get a z-score? A z-score is simply how many standard deviations away from the mean a given score is. So to calculate a z-score, it's simply an observation minus the mean divided by the standard deviation.
T-score is another form of a standard score, and the formula is 50 plus 10 times the deviation divided by the standard deviation. T-score actually is 50 plus 10 times the z-score. So what happens now is where the mean for z-scores is 0, if you substitute 0 in for the z-score, you'll get 50 plus 10 times 0, so the mean of t-scores is 50.
In fact, if you look at this table, this simply illustrates that the mean for z-scores always is 0. The standard deviation always is 1. The mean for t-scores always is 50. The standard deviation is 10. So the only thing that changes in the distribution we've illustrated for you is what's your raw score. Think of your raw score as, is it VO2 max or a bowling score or a flexibility score or a test score. The only thing that would change is what your raw score happens to be. With that in mind, let's illustrate that. Here's a distribution of scores. We have S, or standard deviation, z-scores, which has the same metric. We have t-scores with a mean of 50 and a standard deviation of 10, and then we have percentiles listed. Well, what's your raw score? What values are you working with? If you had VO2 max, as we've illustrated here, the average VO2 max here is 55. The standard deviation is 4. If you're not looking at VO2 max, maybe your raw score consists of bowling, where the average is 200 and the standard deviation is 15. Or maybe it's your test score, where the mean was 60 and the standard deviation was 8. Notice nothing else changed in those distributions except what the raw score was. Using that information and the associated z-table, we can learn a great deal about percentiles and percentages around a particular value. So for example, returning again to our z-table, the numbers down the left are z-scores in whole numbers and tenths. The numbers across the top are z-scores in hundredths, and the numbers in the body of the table are percentages between the mean and any given standard deviation value. So you need to be able to consider how you might transfer from a z-score to a t-score, from a raw score to a percentile, and so forth. And in so doing, it will help you better understand and utilize a z-table and have a deeper understanding of areas under the normal distribution.
So here are the formulas for the z-score and the t-score again. And what we'll first look at is going from a raw score to a z-score. So the z-score is going to be equal to that raw score, x, minus the mean of the distribution from which that score came, and the standard deviation of that distribution.
Realize the z-score and the t-score, the percentile and the raw score for any given point in the distribution don't tell you anything different than any other of them does, but you can refer and translate from one to the other. This is the formula for going from z-scores to t-scores. Notice we haven't changed z-score and t-score up at the top. They remain in all of these slides. If you're going from a t-score to a z-score, the formula would be
the z-score is equal to the t-score for the observed value minus 50 divided by 10.
Here 50 is the mean of the t-scores. Standard deviation of t-scores is 10. If you're going from z-scores to raw scores, you simply change the formula around and you have the x is equal to the mean for the raw scores plus the z-score times the standard deviation for the raw scores.
Going from a raw score to a t-score, first find the z-score, then use the t-score formula. So z-score is equal to the observation minus the mean of that distribution divided by the standard deviation. So then the t-score is equal to 50 plus 10 times the z-score.
If you're going to go from t-scores to raw scores, first find the z-score from the t-score and then use the z-score formula. Notice again the t-score and the raw score formulas are staying with us through all of these examples. You can use one formula if you'd like to, as long as you keep in mind what the mean and the standard deviation is. You have a mean for the raw scores and a standard deviation for the raw scores. You have a mean of z-scores, which is 0, a standard deviation z-scores, which is 1, a mean of the t-scores, which is 50, and a standard deviation of t-scores, which is 10. Knowing those three things and keeping them in mind, you really can use one formula all the time, and that formula happens to be the z-score formula.
Notice that you never know exactly what the mean and the standard deviation of the raw score are going to turn out to be until you have your distribution.
Let's use this information and these formula now to answer a couple of questions. Here's an example. Assume that the mean number of MVPA, moderate to vigorous physical activity minutes per week, is 100, and the standard deviation is 20 minutes. If you have that information and you engage in 105 minutes of MVPA per week, well, let's see. There's a distribution for MVPA. You have a mean of 100, a standard deviation of 20, and where do you fall? Right? You fall somewhere around 105. Well, wait a second. How do I look at this? First, draw yourself a picture. We have a picture. What's your z-score? Figure out what your z-score is, and how can a z-table help me figure out the answer to some questions? There's your 105 minutes. See if you can answer the following questions then. What percentage of people engage in less MVPA than you do? Well, just looking at your point on the graph, you know the number has to be more than 50%. What's your t-score? Well, just looking at the figure you've drawn, you know it has to be greater than 50. What percent of people engage more MVPA than you do? Well, you know it's got to be less than 50. What percentage of people engage in more than 130 minutes? Ooh, you should say that's not very many. What percentage of people engage between 75 and 125 minutes of MVPA? How would you figure that out? By looking at the z-score, drawing a picture. And assume one's percentile is 40. How many minutes of MVPA does the person actually engage in?
Give you a hint on that one, you have to use the table backwards. You have to go into the body of the table to find your z-score that corresponds with 40 percentile.
We have provided you with the answers here, but you should work through each of these using the formula that we provided in this video to help you identify what the values would be for a z, a t, a raw, or percentile for any given value when you are given the mean and the standard deviations.